So in this video, we will see the electric field and the potential due to the conducting sphere. So here I have taken one conducting sphere. This is the conducting sphere I have taken, having some charge on the surface of the conductor. There is no charge is possible inside the conductor, already we know, and the electric field inside the conductor is also equal to 0. Okay, by having this knowledge, now we have to draw how the electric field is there in the region of this one and how the potential is there. These two things we will see, provided there is no charge inside the conductor and there is no electric field inside the conductor. These two things we know already. Okay, then now you see, because of the charge, the electric field in general is given due to the point charge. I am telling E bar is equal to Q by 4 pi epsilon into R square into R cap. So electric field is changing with respect to distance as 1 by R square. So we have the conductor like this. So distance is increased if you go like this. That means with respect to distance on x-axis, here I have taken the electric field is to be reduced because the distance and electric field are inversely related. In that too, it is 1 by R square. So the quick reduction in the amplitude of the electric field is possible as distance is increasing. For example, here you have certain amount of the electric field. Compared to this point, if you are here with respect to this distance, the electric field is to be reduced. Then electric field will be further reduced. Then it is further reduced, becoming 0. This is what I can able to understand. So I will draw that part now. So for example, here I have this much amount of electric field. Then as distance is increasing, that means when you go away from the conductor, then electric field will be reduces and becoming 0. So this is the plot I have drawn for electric field with respect to distance. Now if you are inside the conductor, then how much electric field is there? We know already there is no existence of the charge inside the conductor, so that there is no electric field due to that particular non-existence charge. So inside the conductor you will be having 0 amount of electric field. So but at the outside, the electric field is changing with respect to distance as 1 by R square. This is about electric field versus distance. Okay, in case of this conducting sphere. Now, it is very interesting to observe the potential versus the distance. So we know that potential V is actually work done. So work done or potential is based on the line integral of E bar dot dl bar. That means here distance is there. So how much distance the charge is moving, that much amount of work done is there. That much amount of potential is there. So if the charge is traveling more distance, then more work will be there. More potential will be there. If the charge is traveling very less distance, then less work, less potential. In the concept of the work done or in the potential, we are bringing 1 coulomb of charge from infinity to certain point in the field of the already existed field. So already existing field is there. Within that particular field, the 1 coulomb of charge is to be moved from infinity to certain point. Then we can tell that is the potential of that particular point. I'm not defining the potential difference. I'm giving only potentials at different points. So here we are establishing the electric field due to the conducting sphere. So in the screen, throughout the screen, you can assume the electric field is there due to this conducting sphere. That is already existing electric field. Now we are moving 1 coulomb of charge from infinity to this point. So when I move the point from infinity, when I move the charge, 1 coulomb of charge from infinity to this point, then some work has been done. So at this particular point, some potential is there. That potential I am taking, for example, 1 volt. So at this particular position, from infinity you have traveled, that means 1 coulomb of charge is brought from the infinity to this point. We will assume this is the infinity distance. Now 1 coulomb of charge, if it is brought from the infinity to this distance, then some work is there, some potential is there. Is that potential higher than this 1 volt or less than the 1 volt? It should be higher than the 1 volt only, because from the infinity, if you move up to this point, if it is 1 volt of potential, from the infinity, if you bring the charge up to this point, then more distance, that means more work is to be done, more potential will be there. If you bring the charge from the infinity to this point, so it is more distance, that means here more work, more potential. So this movement of the charge is done to different positions from the infinity distance in the already existing field of the conducting sphere. Don't forget that one. So we are moving the charge from infinity to this point, to this point, to this point, this point, this point, this point, this point, like this. Okay. So when distance is increasing, then potential is also increasing. So how the curve will be available? How the curve will be available means with respect to these points, if you see, the potential is increasing. Okay, from infinity distance. Okay, otherwise from the conducting sphere, if you see, as you are going to the right side, the potential values are decreases, 3 volts, 2 volts, 1 volt, like that. So it will be like this. It is decreasing, finally it will become 0 at certain distance or at infinity distance. It will take like this. Okay, so one thing you have to observe. This is the potential curve V. One thing you have to observe. Electric field became 0 with respect to distance. Potential also became 0 with respect to distance. But what is the change here? This electric field became 0 with the smaller values of the distance only. But potential became 0 with larger values of the distance. What is the reason for this one? Because electric field is changing with respect to distance as square of the distance. 1 by r square is there. But potential is with 1 by distance only. So both are reducing with respect to distance, but electric field will become 0 very quickly because it is proportional to 1 by r square. So denominator is larger. So quickly its value will become 0. Now coming to inside the conductor. So see carefully, as there is no electric field inside the conducting sphere. What is the potential concept? What is the work done concept? Work done is to be taken when the charge is moving opposite to the existing field. So outside the conducting sphere only we have the electric field. Inside there is no electric field. So outside electric field is there. You are moving 1 coulomb of charge. That's why this non-zero potential is existing. Okay, this non-zero amount of potential is existing because the 1 coulomb of charge is traveling in the already existing electric field oppositely. But when you want to brought the electron inside the conductor, hypothetically, because there is no electric field inside the conductor, even though charge is moving, it is not moving in the field. That's why if E is 0, then potential will become 0. So that the potential graph will be, is it 0? Like this can I take? No. This is the wrong approach. Okay. Why? Why means at any point the potential is defined with respect to infinity only. Okay. In the electrical circuit, any node voltage is with respect to ground only. Here, at any point, the potential is defined with respect to infinity only. So, what is the mistake in this one means, inside the conductor, the electric field is 0. It is correct. But inside this particular conductor, we cannot take this potential is 0. Why? So just I will raise this one. What is the reason for this one? If you want to measure the potential at this particular point, the charge is to be moved from infinity to this point. It is not from here to here. Okay, it is not from here to here. The charge, in order to define the work done here, the charge is to be moved from infinity. So you want to define the work here or potential here, but the charge is to be from the infinity means you are traveling all this distance. So it is required to do this much amount of work. For example, it is 5 volts. So to reach this particular point, it requires 5 volts. Then from here to here, 0 volts. Okay, from here to here, 0 amount of work. But to reach this point, it requires 5 volts. So 5 plus 0 will be 5 volts only. Then for example, here if you want to measure. For this particular point also, again, the charge is to be moved from infinity. So the charge is to be moved from infinity to this point. That means again 5 volts of potential is required. Then from here to here is 0. So 0 plus 5 is 5. So that means here also 5 volts only. Here also 5 volts only. Here also 5 volts only. So inside the conductor, there is a uniform potential. Okay, outside it will be like this. Okay, outside it will be like this. Inside it is like this. But outside the electric field will be, quickly it will become 0. Inside there is no electric field. So like this you can able to understand the potential concept and the electric field in the conducting sphere concept. Okay, thank you.